Hello YouTube, RJ. I wanted to talk a little about the upcoming playlist projects that I'm going to be working on the channel. Wanted to bring you guys up to speed a little bit on them and kind of tell you where I'm going and what I'm working on. So basically what we're going to be doing is building a ham radio. My plan is to learn a lot from this. This is going to be a learning lesson. This is not going to be, I just want to build a radio. I've done that before. There'll be a few differences with this one. It's going to, at least to start off, it's going to be totally analog, no digital SI5351 or whatever chips. It's going to be an analog VFO. It's going to kind of change as we go along, because one of the things I'm going to be doing is I'm going to turn this into kind of a myth buster. What I'm going to do is there are so many rules of thumbs and beliefs that you'll read as you read on the different systems, like, for example, oscillators. You know, one guy will tell you, oh, you got to use these kind of caps or it won't be stable. Other people will say, well, you got to use that kind of cap or it won't be stable. So because of that, what I thought I'd do is we will build modules and we'll test them. And what we'll do is try to keep tweaking them to get them to the very best we can. And along the way, what I want to do is I want to do this with empirical data. I want to actually test things and be able to prove what we're saying. So here's what I'm doing. I'm calling it the Lynx Thermal Test Cell. Little oven, foam insulated oven. I used the laser cutter to cut and make an inside box in here. And then it has an external box on the outside. And what happens is, if you can see down in here well, there's actually a 1157 car light bulb in here, and I put a little copper tape to keep it from getting too hot up against the plywood. And there's a couple spacers in there that the floor of this will sit in. And if you can see that I've got a grill basically for the heat to come through. This will drop down and your device under test is going to go on this. It'll drop in there, you'll put it in here, and then what will happen is we'll interface this with our, for example, to do testing with different oscillators and different components in different oscillators. We'll feed the RF out of the oscillator into my Siglent SDG 1032X frequency counter, which I've modified. It's not really a 32 anymore, but we won't get into that. I'm pretty sure most of you know what I'm talking about. So anyway, we're going to use it. Now, it's not known to be the most accurate test device. It's pretty good, but the time base in it is not super accurate. So one of the videos we'll be looking at here very shortly is I have a time base coming for external time base on that. That'll make it very accurate, and we'll use that. And what I want to do is I want to be able to automate the test, record and create graphs, and be able to say, okay, here's how this performed. Here's how this oscilloscope or oscillator performed. Here's how it performed with these kind of capacitors. Here's how it performed when we changed them and put these kind of capacitors on. And hey, you know, we changed from a bipolar transistor to a FET because that's supposed to make it more stable. Did it? Yes. Then we'll stay with the FETs. And what we'll do is we'll work through, and the very first thing we're going to do is look at different types of oscillators. You know, Colpitts. I might build a Hartley. A lot of talk by hams here recently about a very underused oscillator called that you may have heard, called the Franklin oscillator, which solder smoke. Some of them have had a lot of talking going on about how they're ultra stable compared to other oscillators, and they don't know why we never used them. Well, we're going to find out. We're going to find out, are they really more stable? Not, oh, I turned it on and it looks good and I think it's good. We're going to find out. And how this works is this interfaces USB to the computer. As you can see, I have a little Arduino Nano in there. I've got a little relay module to control the light, and I've got a temperature module in there with a temperature probe. So what's going to happen is I can read from software in my Siglent signal generator. I can read the frequency counter. I wrote some software to read it over the Ethernet. I wrote software for the Arduino and on the computer that can read the temperature and can turn the light on. So what we're going to do is this will all seal up, insulated. It'll start up, the oscillator will start up. We'll start a reading, and we'll let the oscillators run, or whatever components we're running, for about 10 minutes to get, okay, they've warmed up. bench warm up, room temperature. Now they've stabilized. Get a reading of, how that looked. Then we'll turn the light bulb on. We'll let the temperature start climbing, and we'll compare how stable they are as the temperature rises. And because we can control this and do this repeatedly over and over again, exactly the same, we can get comparative information on them. So that's what this is about. I'm going to finish it up. You'll see it when it's done. And then we'll jump on updating my signal generator. I'm sorry, can't talk today. My arbitrary waveform generator. We'll update it with a time base to get it really accurate on the counter, and we'll be ready to start testing things. And so at that point, we're going to build some oscillators. We're going to just throw them together with basically the same type of components, put them together, and we're going to test them, and we'll see how they come out. And then we'll pick a winner, and we'll start making changes to it. We'll try all the different things to see how stable a VFO we can build. And whatever comes out being the very best, that's what we're going to use in our radio. And then we'll turn around and we'll go to the next module, and we'll build the next module for our radio, and we'll do the same thing. So along the way, I hope to learn a whole lot. The old typical, I'm not an expert at this. I'm just a hobbyist. I have a lot to learn. I hope as we go along, it'll be entertaining and very educational for you guys. I hope you learn from what I'm doing, and it'll inspire you to do some work in the DIY analog electronic side of it. Digital is somewhat easy for me. Analog, never was a big analog guy. I'm learning. I'm enjoying it. So tune in, keep up. I'm going to put it all together, and this whole thing will be a playlist. We'll start out with building this box, building oscillators, testing them, moving forward. It'll be a playlist. It'll take you right through coming out with the ultimate VFO for our radio. So tune in. If you like what I'm doing, make sure to like and subscribe to the channel. It doesn't cost you anything. You can always unsubscribe later if you don't find the content interesting, and hopefully it will be. So thanks for tuning in. Till next video.